Let's work now on a population growth problem. The graph shows the population of species of bird where T represents the number of years since 2009 and P of T is the population measured in thousands. So T, that is the time, is going to be represented on the x-axis. We're going to call it from now on the t-axis. And P of T, that is our function, will be represented on the y-axis, on the vertical axis. And it will give us the population of the bird. Now, one thing that you need to pay attention to is that the problem says since 2009. So this means that the time starts at 2009 here. So this means that the 0 corresponds to 2009. So 2009 plus 1 is going to give us 2010, plus 2 will give us 2011, and so on. Plus 6 right here is going to give us 2015. Okay, 2009 plus 6 will give us the 2015. So each one of the points on the graph on the horizontal axis will give us a year that corresponds by just a number for t. The PT also gives us the population at the specific year. So the initial population is in 2009 will be 1500. After 1 year it will be somewhere between 1500 and 2000, so somewhere in 1750 and so on. And we can see right here that we have a point that says that is 5,3200. So this means that the population at the year 5, that is the 2014, is going to be equal to 3200. So this is how we read our graph. Now, the graph gives us a lot of information. We have this beautiful point right here, and we also have the y-intercept that basically tells us a lot about the initial population. Now, look at the first question. It says, find a function that models the population in time t. That is of the form P of t equals to P0 e to the RT. Now, too many letters. Okay, fine. Let's see what each one of those letters means. The P0 is going to be the initial population, so nothing else than the P0. And this is easy to find. Why? Because we have it already in the graph. This is 1500, right? When the T is 0, this is 1500. So this is nothing else than 1500. Okay, so we have that. Then we have E, that is the natural logarithm, 2.71. We have R, that is a parameter that we don't know. And T is our actual variable that counts the years. Okay, so the next thing that we want to, since we know the initial population is 1500, then we have some information for this function. This function actually can be replaced now with PT equals to 1500 times e to the RT. Now, we still don't know what the R is. We definitely would like to know what the R is. How do we find this? Well, to find this, what we need to focus on is on this extra information that we have. What do we know? We know that P of 5 is going to be equal to 3200. We have this information. Well, yes, but P of 5 also from the equation that we have right here can be written as 1500 times e to the R5, because t is the number 5. Okay, good. So this is equal to 3200. So now if you look at this equation that you have right here, you can observe that the only variable that you have, the only number that you don't know what it is the R. So if we solve this equation for R, then we will know everything about the initial function. Okay, how do we do that? Well, this is nothing else than solving exponential equations. How do we do that? First of all, we divide both sides by 1500 in order to get rid of the 1500 and leave the power by itself. This will cancel this with that. And if we simplify the 3200 by 1500, we have 32 over 15. So this gives us e to the 5r equals to 32 over 15. Now, we can solve this equation using logarithms. How do we do that? Remember, we consider what is the base of our power. It is e. So we take ln from both sides of the equation, and we have ln of 5r, e to the 5r, sorry, equals to ln of 32 over 15. We use now the power rule in order to bring the 5r down, and we have 5r times ln of e equals to ln of 32 over 15. ln of e is equal to 1. So if we divide both sides by 5, then we know that r is equal to ln of 32 minus ln of 15. I apply here the quotient rule, divided by 5. So if I plug in now into my equation, P of t will look like will look like as 1500 times e to the ln of, let's put it together. I think it's better for us to put it together. Divide by 15 divided by 5 times t. Well, let's look at this together. Can we further simplify it? Well, if you look at your exponent right here, you have e to the ln of a number, and the number is the 32 over 15, divided by 5. I can replace this by, let's look at it, everything else stays the same, so 1500 stays the same, and then I have e to the ln of 32 over 15, right, to the 1/5 times t. What did I do here? Well, you have a fraction at your exponent. It is like if you have ln of 32 divided by 15 times 1/5 times t. So I take the 1/5 out, and I use the property of powers that says if you have ax to the y is equal to ax times y, right? So what I had here, it was ln of 32 over 15 divided by 5. So I took the 1/5 outside of my power. Why did I do that? Well, if you pay attention to what you have now inside your power, you have e to the ln of a number. Now, you have another property that says that if you have e to the ln of a, then this is nothing else than a. And you have e to the ln of 32 over 15. So this is nothing else than 32 over 15. So this means that I can further simplify that, and I can write it as 1500, this doesn't change, times 32 over 15 to the 1t over 5. And that's my function. This is equal to the pt. Can I further simplify it? Well, no, that's as much as I can do, because the 32 over 15 is already in the base of the power here. How am I going to use that? Well, I'll use it right here, where it asks me to find the bird population for 2020. So the first thing that I want you to do is go back to your graph and look at your numbers. The 0, when the t is 0, then the year is 2009. When the t is 1, then the year is 2010, and so on. When the t is 6, then the year is 2015. So when the year will become 2020, then the t will become equal to 11. How do I know that? Because in order to get the t when the year is 2015, and let me write it down, 2015 minus 2009, that I have right here, is equal to 6. And this 6 corresponds to the t, right? So 2020 minus 2009, that is the beginning of the year, will give me 11. And this will be equal to my t. So basically, this problem asked me to find the p of 11. So the only thing that I need to do is I need to plug in the number 11 in my equation. And I have 32 divided by 15 to the 11 over 5. Now, if you want to calculate this, you need a calculator. So we can use the calculator right here and make sure that we enter the numbers correctly in the correct order. So first you put the base, you calculate 32 divided by 15. The number is 2.1333 repeatedly. And then this is going to be the base to your exponent. So you use this x to the y. But now the y is 11 over 5. So either you calculate 11 over 5, that is 2.2, or what you need is parentheses here in order to put 11 divided by 5, 2.2, it calculated that. Your result is 5.2957, and you multiply this by 1500. And the result is 7,943. And that's your answer for this problem. To approximate 7,944. But